Hi, Pre-Calc people. We are at lecture number 2 using computer. Make sure you pay attention. There will be a surprise slipped in the middle of this one. Okay. Today we're going to talk about transformations of graphs. Okay. Okay. Basically, what it comes down to, if you have a function y equals, let's say we're just going to use x squared. If you see, by the way, this whole slide, NW, noteworthy, guys. If you see some number in parentheses with the x in the function, that means you are going to move, well, here, to the left or right. Or right. C spaces. Okay? So when it's there, basically what it means is if it's negative C, you go to the right, and if it's positive C, you go to the left. So you go opposite of what you think you would. Okay? So I'll give you guys a second to write that down. Now the other thing you might see, no pun intended, is if, let's add some letter. Let's say we add the letter H. Why am I choosing these arbitrary letters? Well, you'll see. Okay. So H is going to either move graph up or down. Now this one is what it seems. If H is negative, you go down. If H is positive, you go up. I mean, that's all there is to it, guys. Oop, I'm going to add this. H spaces. Okay? So go ahead and pause if you need to. This is pretty important stuff. Again, if you see a number in parentheses next to your x, you're moving to the left or right. If you see it outside and you see your basic function, you know your x squared. Remember those 12 basic ones you guys all have memorized now, right? Right? Okay. So the H tells you go up or down. Now guys, a big piece of advice when we're doing it this way is if you have a question, put question mark by notes. I'll go back to it. Oh, too much info, too much info. Too much info. Curtain. I brought the happy blue over. Okay. So what this asks you to do is think about that good old graph, absolute value of x. Now, what does this transformation do to the absolute value of x? Okay. Guys, don't have to take notes on this, but you do need to listen to it. The surprise will come halfway through this one, okay? So, first thing you gotta ask yourself, is there something next to your x? In parentheses next to it, and there is not. So we are not moving to the left or right. But I see this plus 4 out here. That plus 4 is kind of like that H from the first slide. So since it's positive, it tells us we're going to move the graph up. It's a translation up. Okay? Translation up for movement. So our original graph would look something like this. Oops. Oops. But now we're just going to move it 4 units up. So we take this 1 point, we go 1, 2, 3, 4, and that's going to be our new graph. Okay? By the way, here's something else I want you to think about. What would you call a camel with 3 humps? I would call it hump threes. Huh? I'm sorry, surprise wasn't as good as what you guys probably anticipated. Okay. Here's the type of homework problem you guys are going to see. This is noteworthy. So I'll give you guys a second to go and write that down. Okay. So you have this part written down, right? Now go ahead and draw these three graphs too, if you haven't already done so. So these three graphs are noteworthy as well. Okay? I got it. If you don't, pause it. Let's take a look at this guy. This is our original graph of y equals x to the third, right? What's happened to it? Well, we didn't move to left or right. It looks like we moved down 1, 2, 3, right? So if we're moving down, that means you are putting something in parentheses. That means you're subtracting 3. Okay? If you want to plug this into your graphing calculator to see if it's working, go for it. Let's take a look at this guy. Again, our original graph is y equals x to the third. Well, are we moving up or down? It doesn't look that way to me. Looks like we move over to the left 1, 2. So if we're moving left or right, that means this x is going to end up being in parentheses, right? Oops, that's a 3. Now we're going to the left, so that means this guy is going to be positive. We're going to add 2 to it. And we got one more. Again, we're looking at y equals x to the third. We have this point right here. And now we got to ask ourselves, am I moving to the left or to the right? Well, in this one, or up or down, but we are not moving up or down. So we know x is going to be in parentheses. Put 3 up here. Now, I move over 1, 2, 3 to the right, so that means I subtract my 3. Okay, so there you go. There's our answers. Okay. Again, if you have questions, just write question mark by it. Make sure to touch on those next time we see each other. Okay. Next thing I want to talk about is when we reflect over the x and the y axis. So, when you do a reflection over the x-axis, guys, this right here, very, 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 very noteworthy. So when we reflect across the x-axis, you just put a negative in front of your function. You go across your y, you just put a negative in for your x. Oops. Oops, oops, oops. Okay, so I'm going to give you guys a second to go ahead and write that down. I got it? Alright. And I'm going to give you guys an example. And then that'll be it. That'll be on this one. So let's take a look at, let's reflect y equals x squared, over the x-axis. Okay. So quick review, add an L here. Across the x, you put the negative in front of the entire function. Okay, so you can think about, I could have written this f of x equals x squared, right? So if I put a negative sign in front, let's put a negative over here. Okay? So that means if my original graph, which I'm going to draw in red, looks like this, y equals x squared. My new graph, which I says y equals negative x squared, should look like this. It should be a mirror image of each other across this good old x-axis, right? Okay, so make sure, if you're reflecting more difficult ones, make sure that that is distributing through to everything. Now let's do the same thing. Let's reflect. By the way, guys, noteworthy for sure. Let's reflect y. Uh-oh. I'm going to change it up again. Plus 2. No. I'll take a ball for that. X plus 2 squared across the y-axis. Okay, from what we were doing before, I know x squares look like, or x squared look like, so I know x plus 2 means I'm going to move this point 2 to the left, and I'm going to draw my x squared function, right? Now I'm moving across the y-axis, so that means I'm going to have to take my f of x I'm going to have to add a negative in where my x is, right? It's right here. So that means wherever I see an x, I'm going to add a negative, right? And now when you graph this beast, which is going to be this, and you can use a calculator for this one if you don't see it, what you're going to find is when you reflect it over, it's going to look like this. Okay? So again, when you reflect over the x-axis, you make this mirror image. You add a negative in front of your entire function. When you reflect across the y-axis, you just put a negative in front of your axis in the function. Okay. Again, any questions? Don't be afraid to ask. Put your question marks. There'll be time at the beginning of class for you guys to ask them. Okay? Hope you enjoyed.